Hello everyone, my name is Yaswant Singh. I am a student of MCF from Kite Group of Institute. Today I am going to talk about brain-computer interface. A brain-computer interface is a direct communication pathway between brain and external devices. Brain-computer interface is a technique which allow a human to control computer, peripheral, or other electrical devices with thoughts. It does so by using electrodes to detect electrical signals in the brain, which are sent to a computer. The computer then translates these electrical signals into data, which is used to control the computer or a device linked to a computer. Uh, Now come to its history. Volbau and colleagues, 40 years later in 1970s, researchers were able to develop primitive control system based on electrical activity record from the head, means brain. The Pentagon Defense Advanced Research Project Agency research conducted by George Lawrence and co-workers focus on developing technique to improve the performance of soldiers in tasks that had high mental loads. Expanded its focus toward a more general field of biomatics, whose goal was to explore the possibilities of controlling a device, uh, the real-time computerization process of any biological signal. American scientist Peter Berner composed a message simply by concentrating on a display at Europe's Research and Innovation Exhibition in Paris in 2006. Uh, so, how the brain turns thoughts into action? The brain is full of neurons. These neurons are connected to each other by axons and dendrites. The neurons, as you think about anything or do anything, are at work. Your neurons connected with each other to form a super highway for nerve impulse to travel from neurons to produce through hearing, speech, or movement. If you have an itch and you reach to scratch it, you receive a stimulus, an itch, and react it to respond to the stimulus by scratching. The electrical signal that generate the thoughts and action travel to a rate of about 250 feet per second or faster in some cases. So come to the interface of BCI. The easiest and least invasive method of a set of electrodes, a device known as electroencephalograph EEG, attached to the scalp. The electrode can read brain signals. To get higher resolution signals, scientists can implement electrodes directly into the gray matter of the brain itself, or the surface of the brain beneath the skull. Types of BCI. It has two types: invasive and non-invasive. Invasive BCI. Invasive BCI research has targeted repairing damaged sites and providing new functionalities to paralyzed people. Invasive BCIs are implemented directly into the gray matter of the brain during the neurosurgery. Using implanted again the brain that have hundreds of pins less than the width of the human hair pro- protruding from them and penetrating the cerebral cortex. Scientists are able to read the firing of hundreds of neurons in the brain. Now, non-invasive BCI. The easiest and least invasive method is a set of electrodes that this device known as electroencephalograph EEG attached to the scalp. The electrodes can read the brain signals. Electroencephalograph is the recording of electrical activity along the scalp produced by the firing of neurons within the brain. Major trends in the worldwide BCI. BCI research worldwide is extensive and rising, especially in China. BCI tech rapidly approaching the level of first generation medical practice clinical trials and invasive BCI technology, home use of non-invasive electroencephalograph based BCI. Example: consumer electronical and emotion and neurosky. BCI research worldwide is uneven. Invasive BCI almost exclusively in North America, non-invasive BCI system in Europe and UK, math algorithm in China, BCI robotics in Japan. Now come to the advantages of BCI. It allows paralyzed people to control prosthetic limbs with their mind, transmit visual image to the mind of a blind person, allow them to see, transmitting auditory data to the mind of a deaf person, allowing them to hear, allow gamers to control video games with their minds, allow a mute person to have their thought displayed and spoken by a computer. Disadvantages of BCI. Research is still in the beginning stage. The current technology is crude. Ethical issue may prevent its development. Electrodes outside the skull can detect very few electrical signals from the brain. Electrodes placed inside the skull creates scar tissue in the brain. Now we come to the conclusion part. As BCI technology further advance, brain tissue may one day give way to implanted silicon chips, thereby creating a completely computerized simulation of human brain that can be augmented at will. Futuristics predict that from there, superhuman artificial intelligence won't be far behind. That's all. Thank you.